Hello, hello students. Is that audible? The video is clear. Good morning. Good morning. Good morning. Is that audible? The video is clear. Very good morning. So come to the live session, all of you. Yes, come to the live session, all of you. Yes, good morning, my dear students. So every day, morning 6 to 7, live classes will be start. That is every day concept from each chapter we will discuss. Then afternoon 7 to 8, numerical problems based on EAPCET or JEE means examination. Previous year questions they will discuss. It will be discussed in the afternoon evening session, that is 7 to 8 o'clock. So now only concepts, the morning every day, daily one chapter. So like that, nearly 30 chapters are there in the first year and as well as second year. So concepts we will discuss. So mainly in the EAPCET examination point of view or the JEE means second session examination point of view. So in each and every chapter, what is the main important points? So what should be remember in the particular chapter that we have to discuss? So in this videos, the first one is atomic structure. So in the atomic structure, first what we have to discuss, so all the fundamental particles, whatever the fundamental particles are there. Fundamental particles. What are the fundamental particles? Everyone knows. One is electron. Electron. So electron, about the electron, what we have to remember? First one, it is discovered by J.J. Thomson. J.J. Thomson. The next, the charge of or absolute charge of electron. Absolute charge you have to remember, that is minus 1.602 into 10 to the power of minus 19 coulombs. This is the absolute charge. The next, relative mass. Relative charge. Relative charge. That is simply we have to take minus 1. The next, absolute mass. Absolute mass of electron. Absolute mass of electron. Absolute mass 9.1 into 10 to the power of minus 31 kg. Then relative mass. Relative mass of electron, that we have to take 0.00054 units. Atomic mass units you have to take. This is about the electron. Then one more fundamental particle that is there. So second one is what? Proton. So it is discovered by Rutherford. Rutherford. Then absolute charge. Absolute charge, that is plus 1.602 into 10 to the power of minus 19 coulombs. So look at electron absolute charge, proton absolute charge, both are same. The sign will be different. Here minus charge, then here positive charge. Then relative charge. Relative charge if you take, that is plus 1 you have to take. Then mass. Mass, which is absolute mass of electron, absolute mass of proton if you take. Absolute mass of proton if you take, that is 1.672 into 10 to the power of minus 27 kgs. Okay, then relative mass of proton, that is equals to 1.007676 atomic mass units have to take. So these are the both two fundamental particles. One more fundamental particle is there, that is neutron, right? So we have to discuss about the neutron also. So note it all of you. Then we'll discuss third one, that is, so while teaching you have to note it each and every point. So all these are important points only that we are discussing it. This third one, neutron. So neutron discovered by James Chadwick. Then absolute charge of neutron is 0. Then relative charge also 0. Relative charge, that is also 0. Then absolute mass if you take, absolute mass of neutron if you take, so absolute mass of neutron if you take 1.675 into 10 to the power of minus 27 kgs. Then the relative mass if you take, relative mass of neutron if you take, so that is also 1.00, then 86 atomic mass units. So these are the fundamental particles. Sir, here for proton and as well as electron, even you have to remember charge to mass ratio of electrons, charge to mass ratio of the particles. So charge to mass ratio of electron is what, and charge to mass ratio of proton is what, that we have to remember. So note it all the fundamental particles. Then we'll go for charge to mass ratio of electron and as well as proton also you have to remember, that are very important. So ikkada charge to mass ratio, nothing but E by M. Charge to mass ratio, nothing but E by M. Charge divided by mass. So charge divided by mass of electron if you take. So charge of electron, now we are discussing, right? What is that charge of electron? So minus 1.602 into 10 to the power of minus 19 coulombs. Then mass of electron, how much? The mass of electron is 9.1 into 10 to the power of minus 31 kgs, right? So these are the coulombs that are cages. So now if you take that is about 1.755 into 10 to the power of 10 to the power of 11 coulombs per kg. 11 coulombs per kg. This is such charge to mass ratio of electron. Then in case if you take second one, charge to mass ratio of proton if you take. So you have to remember that the mass of electron is very, very less when compared to the mass of proton. So that is what charge to mass ratio of electron is greater once the denominator value is very less when compared to other one, then automatically the value will be increases. The next, the charge to mass ratio of proton, of course, 1.602 into 10 to the power of minus 19 coulombs divided by. Then mass of neutron, mass of proton, we are already discussed, that is 1.607, sorry, 672 into 10 to the power of minus 27 kgs, right? So then this value you can get it is charge to mass ratio. So that is 9.75 into 10 to the power of 7 coulombs per kg, remember. So which value is greater? This value is greater. So when comparative to this value. So remember the mass value increases, mass value increases, mass value increases, charge to mass ratio value decreases. Charge to mass ratio value decreases. This point you have to remember. So because they will ask a question, arrange the order of charge to mass ratio of following particles. So such type of questions they will ask. Actually options they will mention like this: A, then electron, B, proton, C, neutron, then D, hydrogen atom, like this. So where the mass is greater, there charge to mass ratio is very less. Where the mass is very less, then charge to mass ratio is greater. So we know that A is greater here because of electrons mass is very, very less. 10 to the power of minus 31 kgs means very less. Then next A is greater, then next B is greater, then next C, then after D. This is the charge to mass ratio order. Okay. So such type of questions they will ask in the examination, that you have to remember. So next we have to go for the atomic models. So whatever the atomic models are there, that atomic models we have to discuss. Yes. The relative mass, nothing but relative charge, nothing but it is a approximate charge. So absolute charge, nothing but even it is in the coulombs. So that you have to remember, right? So next, come to the atomic models. Atomic models. The first one it is Thomson atomic model. Thomson atomic model. Thomson atomic model. So this is explained by J.J. Thomson, right? Explained by J.J. Thomson. J.J. Thomson. This is also called as plum pudding model. Plum pudding model, or watermelon atomic model. Watermelon atomic model. Watermelon atomic model. Why we are calling the watermelon atomic model or plum pudding atomic model? Sir, according to J.J. Thomson, sir, atom is arranged like a watermelon. Sir, here if you cut the watermelon, then it will be visible like this, right? Sir, here seeds will be present in it. Then red color pulp is arranged inside the fruit, right? So whatever the seeds are there, these are the seeds. These seeds are act as a electrons to neutralize the atom. Red color pulp is uniformly distributed throughout the atom according to him. So whatever the pulp is there, that is act as positive charge. Then so seeds which are act as electrons. So these are the seeds. Seeds are act as electrons, right? So this is Thomson atomic model. So that is what we are calling it as. Then plum pudding model or watermelon atomic model. So why we are calling the watermelon atomic model? Because of so like watermelon, the seeds are entire atom, it is distributed. The pulp is neutralized by that particular seeds. Seeds are negative charges, then pulp is positive charge. So according to Thomson, then positive charge is distributed throughout the atom uniformly. So next we have to discuss about the Rutherford atomic model. Rutherford atomic model. Second one, Rutherford atomic model. So Rutherford atomic model, it is also called as nuclear model of atom. Nuclear model of atom. Why we are calling the nuclear model of atom? So why we are calling the nuclear model of atom? So because all the atoms, so electrons are revolving around the nucleus. So like planets are revolving around the sun. So that is given, that is Rutherford. So how it is given Rutherford? Actually based on Rutherford alpha ray scattering experiment. Based on Rutherford alpha ray scattering experiment. Alpha ray scattering experiment. Alpha ray scattering experiment. This is mentioned. So alpha ray scattering experiment is what? So here alpha rays, when it is passed through, so a thin gold foil. Alpha rays are passed through a thin gold foil. Then how the alpha particles are behaving with that gold foil? So based on that experiment is given actually. So look at, just assume it. This is the source of alpha particles. So alpha particles are produced from it. Here one of the thin gold foil is arranged. So this is just assume it as gold foil. Sir, around that gold foil, fluorescent material is arranged. The fluorescent material, nothing but, sir, any light when it is touched to this, when it is hit, a spark will be visible at this place. So zinc sulfide, fluorescent material enti ante zinc sulfide is the fluorescent material in this case. Sir, alpha particles, when it is passed or when it is passed through the gold foil, what happens? Sir, here one of the experiment is done. So look at what happens in this. Sir, for example, this is the gold foil. This is the gold foil. Right. So here in the gold foil, gold atoms are there. Gold atoms are there. Like this. Gold atoms are there. Once alpha particles are passed through it, almost all the alpha particles are passing through it. Passing through the gold foil without any deflections. Without any deflections, almost all the alpha particles are passing through in it. Like this. The very few particles. Actually, so if you observe the atom, like this, the here nucleus will be present. Then alpha particles are passing through the gold foil without any deflections. Sir, almost 99% of alpha particles are passing through it. Very few particles which are near to the nucleus, that are deflected like this. So the very few alpha particles which are near to exactly to the nucleus, that is completely bounced back. Sir, such type of particles which are completely bounced back, that is 10,000 in 1. సో 10,000లో ఒక్క ఆల్ఫా పార్టికల్ మాత్రమే ఇలా బౌన్స్ బ్యాక్ అవుతుంది కంప్లీట్లీ బౌన్స్ బ్యాక్ విత్ 180 degrees. Very few alpha particles such as which are near to the nucleus, that will be deflected like this. But maximum alpha particles are passed through the gold foil like this. Okay. So based on this experiment, he given some of the main important points. So first 3 observations we are observed that. One is almost all alpha particles are passing through the gold foil. Then second one is, so very few alpha particles which are near to the nucleus that are deflected with some angles. Then third one is, so 10,000 in 1. Then such type of particles, the very few alpha particles which comes exactly near to the nucleus, that is completely bounced back with 180 degrees. Based on these 3 observations, he has given 3 conclusions. One is, then why almost all the alpha particles are passing through the gold foil? The mainly because complete atom, the atom is empty. There is no any particles in it. There is no fundamental particles in it. So that is what atom completely empty. That is what all the gold foils are passing through in it. Then second one, the mass of the atom is located at exactly center of the atom. The mass of the atom, it is located at center of the atom. That is called, they're mentioned, it is a nucleus. So based on this experiment, he is mentioned, so a nucleus of atomic size, that is 10 to the power of minus 15 the meters, the nucleus size they're mentioned. Then next one more, sir, electrons also present, so where the located positive charge, that is revolving around the nucleus in the circular paths. So that is what, according to the Rutherford atomic model, he is given 3 points. One is, so almost total atom is empty. The positive charge is located at center of the atom. Electrons are revolving around the sun electrons are revolving around the nucleus, how the planets are revolving around the sun in a circular path is given like this. So that is what the Rutherford atomic model is also called as nuclear model of atom. The first, what he told, almost atom is empty. That is the reason, due to that, all alpha particles are passing through in it. Then next one, positive charge of atom is located at center is called nucleus. Electrons are revolving around the nucleus. How planets revolving around the sun, planets, how they are revolving around the sun, same like that electrons also revolving around the nucleus. So that is why we are calling it as a planetary model of atom. Planetary model of atom. Clear? So Rutherford atomic model is also called as planetary model of atom. So next main important that we have to discuss, that are isobars and isotopes, then isotones. So next one, isotopes. Same atomic number, different mass number, same atomic number, different mass number, are called isotopes. For example, so hydrogen isotopes, if you take hydrogen 1 1, then 1 2, then 1 3. So what is this? Protium, then this is deuterium, then this is tritium. Clear? So next, sir, if you take protium, then look at 1H1, I told. So protons are 1, then electrons are 1, but neutrons are 0. It's very, very important. The atom which do not contain neutrons, the only protium. Then deuterium, if you take, so 1H2, the protons are 1, electrons are 1, neutrons are 1. So here mass number, in case if you take mass number, nothing but protons plus neutrons, So protons, how many are there? 1. Then neutrons, how many are there? 1. The total is what? Mass number 2. So mass number 2 because of protons plus neutrons. The next tritium, if you take, tritium, that is 3, H13. Number of protons are 1, neutrons are 1, number of protons are 1, neutrons are 2, then electrons are 1. So in case if you take mass number here, mass number that is A, it is equals to protons plus neutrons. Protons are 1 plus neutrons are 2, totally 3. So this is what? Tritium. Okay. So these are the isotopes. Isotopes, nothing but same atomic number, different mass number of the elements are called isotopes. Isotopes. Then what are the isobars? Then isobars. Isobars. Same mass number. Same mass number. Same mass number. Different atomic number of. Different atomic number of different elements. Different elements. Different elements are called isobars. Isobars. So example for this, carbon 612, then carbon nitrogen 614, nitrogen 714. So mass number is same. Mass number is same. So such type of compounds are called isobars. Then masses are, atomic masses are same. Then atomic number is different of different elements. Then next, isotones. Isotones. Then same number of neutrons. Same number of neutrons. Same number of neutrons. Same number of neutrons. Different elements. Different elements if you take. For example, argon 18, argon 1840. Sorry, isotones, right? The isotones. Isotones are carbon 614, then oxygen 816. The number of neutrons are 8 in it, even 8 in it. So how it is? So number of neutrons find out cheyalante A minus Z you have to take. So A minus Z, A is 14, mass number is 14, then minus 6 equals to 8. Then even here also, the number of neutrons equals to mass number minus atomic number, that is 16 minus 8 equals to 8. Okay, so these are the isotones. Isotones.